Hello everyone, this is AE357 Petroleum Technology. We are in chapter 6 for in the textbook. This chapter is about thermal cracking and coking. We have learned about the basic separation in CDU crude distillation unit and the VDU vacuum distillation unit, and some reactions to improve the octane quality of the products. Refer to the reforming and isomerization. Considering here the bottom from CDU and VDU are listed. You can see that there is a higher boiling range is presented for the VDU residue, and the product of vacuum bottom is quite thicker based on the lower API and has more sulfur content. When we look at the amount of the bottom disease, we found that 16% is still here, which is still in the great amount that we should do something to make the product beneficially. In general, what we can do to the bottom disease is 1. To sell for the road construction, for the roof repairment, or to sell as a fuel oil. Another way to make use of that is to send those residues to the thermal cracking. The heavy residues that go through the thermal cracking process will produce the product containing olefins or even aromatic hydrocarbon, which may present or maintain or remain some sulfur content in high amount. However, for the light residue, that will send to the coking process, this will squeeze light hydrocarbon out, and of course the sulfur content in the light hydrocarbon will quite low. And another byproduct that we will get from the coking unit is a coke. Now let's look at coking reaction first. When we talk about coke, it is created from the condensation of polynuclear aromatic hydrocarbon. Coke is referred to hydrocarbon which has the lower hydrogen-carbon ratio. In this reaction, we will get the light hydrocarbon with a solid form of coke precursor here. Some reaction of this also produce byproduct hydrogen as shown in this table. This data on the thermodynamic Gibbs free energy can give some understanding that the reaction like to take place at the high temperature. So at low temperature, some reaction still have the delta G in positive, but when it moves to high temperature, delta G for most reactions become negative. This also provides the equilibrium constant, comparing between two cases of 500 and 1000 Kelvin. Big positive value in power is found at 1000 Kelvin, while the negative value in power is shown for the 500 Kelvin, meaning that the reaction is favorable at high temperature. The coking process requires extremely high temperature. As you can see here, they require higher than 450 degrees Celsius in all cases. In the thermal process, temperature condition for the process is quite low comparing to what temperature they use for the coking. Three types of process are generally presented, including with baking, delay coking, and frit coking. As you can notice from the operating condition here, with baking takes a mild condition compared to other two types. In case of with baking, the main purpose is just to reduce the viscosity of the residue streams and make a commercial grade of fuel oil. Let's consider about the with baking phase. There are two types of the commercial with baking unit. One is coil type. The other one is the soaking type. Sometimes we call coil type as a furnace type as well. For the coil type, is operated at the low less than time, around 1 to 3 minutes. While the soaking type, we do have to put another adiabatic drum after the coil or furnace. Certainly, the stream is held in longer time comparing to this type. You can see operating temperature between these two types are different based on how long the stream is in the reactor. In this case, higher temperature is used, so the less than time in this type must be shorter than this type. The feed to this system is from the CDU and VDU resist and charged into the unit. The reaction is taking place at the desired heating zone. The effluent for both cases is quenched with a quenching media to stop the reaction, and it's sent to the Wisbaker fractionator for the separation further. And according to this figure, you will see that gas oil or Wisbaker residue are used as the quenching media. Well, this is a typical view of the Wisbaking process. You can see that about 25% will be used, and more than 75% remain as tar. And of course, you can see you will see some sulfur when you look at this table. You can see some sulfur still maintained in the tar. and of course other light products here. So we need to do some treatment before using. This slide will show you about how to make the material balance around the whisk beaker. Empirical equation has been established for approximate material balance for the whisk baking case, which requires only three information such as how much sulfur in the feed, what is the API for the feed in the beginning, and also how much the conversion is. Then you can calculate the product yield and how much sulfur remains for each yield. In the case of soaking type, the residence time inside the drum is dependent on the operating temperature in the soaker. As shown in this table, higher temperature, shorter in residence time. Now we come to the second type of coking unit, called delay coking. A system of delay coking requires two drums. For the coking reaction, operating temperature is a bit higher comparing to whisk baking unit. Look at the process here. The vacuum residue, or VR, from the VDU will pass to the heating trains before entering the bottom of the flash zone in the distillation column. This is just like a preparation procedure to preheat the VR. Then it will be heated again in the furnace, and then the VR becomes hot oil, becomes just like hot oil and some partial boiling oil, I think. Of course, this will create some vapor liquid itself of the hot oil feed stream. Now it is ready to, fed into the empty drum. So we have two drums. One drum is working, one drum is during the decoking process. Vapor in this oil, after they generate the vapor liquid equilibrium, vapor in this oil will help to warm up or heat the empty drum. Hot oil gradually fills the drum. Some hot oil then gradually cool down and form coke while it is fed into the drum. Of course, vapor products will flow out to condense at the distillation column for the further separation. See, during the filling step, on the outer drum of the process, decoking is taking place. High pressure water is supplying together with the drill stem This is high pressure of water and the stem. When this stem pass into the drum here, the cutting head is expand just like that and rotate to cut the coke out of the drum to the coke pit down below. And the table show here is the list of the time required to make the complete circle. Of course, they may have the coking operation time of one day, decoking 1 day, and other preparation step for another day. So this is the picture of the coke pit and the way that drill stem is going to. First, they will go to make a hole and move up again and make the cutting blade expand and start to cut. The coke fall down to the coke pit here. Let's see how much we can make use of the product. Around 70% of the product oil is produced, while 30% still in the coke pit. To be clear in terms of how the process looks like, I would like you to follow the clip in the YouTube. Well, operating condition and the feed characterization will produce in different kinds of coke. Coke types in spong, shot, and needle could be produced based on the different conditions here. Shot type is one with the highest sulfur content, and shot and spong one can be further used for the fuel source, while the spong and needle types are good for the erector. Picture of different cokes are showing here. This is look like spong. This is look like when we expand by the SEM. You can see some kind of just like needle, so that's why they call needle one. Well, this example shows material balance in coking unit. How much what the product distribution is. So you can write down here. And of course you can calculate for how much the sulfur still showing up in each product. And also the API for each one. So what we can use this information is to think about how to make use of that products, and what else the unit that we should use, put it later to purify the product more. Now come to the third type of the coking unit, which is fluid coking. It consists of fluidized bed reactor and fluidized bed burner. This is a reactor, this is a burner. Vacuum resist is heated before feeding into the scrubber, which is located above the reactor, to recover fine coke particle. The heavy hydrocarbon that mix, this is the fine particle, this is a heavy hydrocarbon. After scrubbed, that heavy hydrocarbon containing a fine particle, it will be recycled to the reactor in slurry form. This feed is cracked to vapor and lighter gases, which pass through the scrubber to the distillate or the fractionator later on. Well, coke produced in the reactor is laid down on the coke bed particle. Part of the coke will flow into the burner. So we need to add air here. About 50 or 30% will be combusted with the air in the burner here. So the rest of the coke will be transferred. Some of the coke will be transferred back to the reactor again for more cracking. Some of them will be collected as a net coke. But this is a product distribution of the fluid coke, and it is declared that about 80%, you can see from here, 11 plus here. About 80% that we can utilize for the fuel oil, while only 20% still in the coke form. Okay, students need to study carefully on the end of this use for each type for each type of the GU. I hope this clip can help you to understand the basic of thermocracking and coking. First, do more study in the textbook. Thank you for watching and goodbye.